Hi everyone, so the first thing that I want to show you this week is what happens with floating point numbers when we try to use extremely large numbers. So I'm going to give you some examples here. If I take e to the 10, I get a certain number. If I go e to the 100, then I'll get some other number. If I go e to the 1000, well, this is gigantic. This is actually so large that it cannot be represented as a floating point number, and so what we get is this result INF here. This stands for infinity. And so the floating point system actually encodes this special case to represent the value of infinity, and it arises when you try to do a calculation which is too large to be represented, and this is called overflow. So we say that this calculation has overflowed, and the result is this infinity. We would also get infinities if we try to do things like divide by zero. Now, some properties of this floating point infinity representation. We can get it in MATLAB by typing INF. There are actually positive and negative infinities, and so these arise in calculations if the answer would go towards negative infinity or positive infinity, respectively. What you can do is determine if a value is infinite. There is a function called isInf, which will return a true or a false value, depending on whether that value is infinity or not. So I want to show you a case where this matters as far as doing calculations. So consider that we had this system, this expression that we wanted to evaluate, so x on x squared plus 1. And so if x becomes extremely large, then we actually have a problem here. And so for x is large, that x squared is going to be gigantic. And what will happen is that x will overflow to infinity. And so then we will get something divide infinity, which is 0. And so we actually have a situation for an expression like this where the input values can be represented. The actual answer can also be represented as a floating point number, but we're not going to get there because the intermediate step falls outside the range of representation. And so we'll get that infinity, which will just completely wipe out our answer. And so what we can do, if we know how floating point numbers work and we understand this, what we can do is we can rearrange this formula. I can divide top and bottom by x and I get the expression you see on the bottom. And so this is the exact same thing mathematically, but this will behave better from a numerical standpoint. So let's actually run through that and I will show you how this works. So I'm going to start with a nice value of x, and I'm going to write out the two different forms of this expression. So that was the first one. The second one is where we have divided through by x. And so no semicolons here, so when I run this, MATLAB is going to print out those values. I'll put a CLC at the top so that the screen will be cleared. Let me show you. If I run this, I get now the answer evaluated two different ways, and I see the same answer. So now I'm going to start making my value of x bigger. And so for 10 to the 10, it behaves. For 10 to the 100, it behaves. For 10 to the 200, I now have a problem. And so you see in the first case here, the answer evaluated to 0. That's actually not the correct answer. The correct answer would be this expression down here. And so you see what's going on. If we have an understanding of how floating point numbers work, we can recognize the fact that that this calculation here will have this overflow to infinity with the result of the x squared. Anything divided infinity, whatever the number is, x divided infinity is always going to come out to be 0. And so this expression actually will not work for very large numbers, whereas the one on the bottom actually will. And so this is something that you should know about, because you may find that you are getting these overflow problems in your calculations, and actually you can fix that sometimes by simply rearranging the expression mathematically.